the last of our preliminary topics when thinking about solutions, so we've talked about concentrations, concentration units, and also how do we dilute solutions and how do we calculate those dilutions. We'll get more practice with that. The last idea that we have before we get into talking about chemical reactions is the idea of electrolytes and non-electrolytes. And this is a really key idea. So there are different things that can dissolve in solution. Let's just think of a couple examples that come from food. So it's pretty common to dissolve salt, table salt, in water. So that's something you can do. You can also dissolve sugar in water. But the way that these two things behave is actually very different because of the type of compounds that they are. So table salt, as a reminder, is sodium chloride, and this is an ionic compound. We know that because it is composed of a metal and a nonmetal, and we know that the ions that form this compound are Na plus and Cl minus, sodium and chloride. And the way we represent this compound in terms of its formula units, it's a bunch of repeating ions. We have a bunch of sodium ions next to chloride ions, and the positive and negative charges are holding this compound together. So we get this sort of repeating structure. This is a simplified view of it. I don't have the sizes of the ions right for one, and for two, it's actually three-dimensional, right? I'm just drawing it in 2 dimensions, but this will extend in and out of the page as well as the way I'm drawing it. But that's what this looks like. Sugar, on the other hand, is something like sucrose, or I think I'll use glucose because it's a little bit simpler. Sugar is something like, I don't remember, I think it's C6H12O6 is the chemical formula for, I'm pretty sure this is glucose. This is a little bit more complicated, but this forms individual, and I'm not going to try and draw the actual structure, but it has distinct, let me try and draw that, it's, I don't know, something like this. But rather than being this repeating structure, each of these is a sugar molecule. We'll look at what these actually look like later in the semester, not at sugar specifically. If you take organic chemistry, you'll get to talk about sugars in more detail. But these form distinct units. They're separate from each other. So what happens when these dissolve in water? What's the difference here? Okay, so let's think about first our salt in the water. I do want to keep this here. So when we put salt in water, what happens is we have a bunch of water molecules that come and they break up this crystal structure. Water has the ability to bind to ions, either positive or negative. There's sort of positive and negative sides to water molecules. And so they will come in and they'll break this up and they'll surround these individual ions that I've drawn here. And that's what causes them to dissolve, is that they separate. And so these will be surrounded by water molecules that keep them away from each other. And that's why salt doesn't stay as crystals when you put it in water. The water breaks up the sodium and chloride, which is what normally holds those positive and negative charges are normally what hold your sodium chloride together, and instead they get separated into these individual ions. Now our glucose, on the other hand, our sugar, or sucrose, we could put, there's multiple types of sugar, but these are also going to get broken up by water. They clump together and form sugar crystals as well, but when they dissolve, they don't break up. It breaks up the individual molecules apart from each other so they don't form a solid anymore, but they're still surrounded by water molecules, but they don't separate into multiple things. Whereas our sodium chloride separates into these individual sodium, chloride and sodium separately. And the key difference here is that our sugar, there's no ions here. So there's no positive charges, no negative charges, those are not present. Whereas in the sodium chloride example, our table salt, we have a positive ion here, a positive ion here, a negative ion here. We do have plus and minus charges that are just floating around in solution. Now, what practical difference does this make? Well, for one, it means that you get more stuff in solution with ionic compounds when they dissolve. And this is what we mean when we talk about electrolytes. So just to define these two specific examples we're looking at, sodium chloride is an example of an electrolyte. And Gatorade prides itself on having lots of electrolytes. It has lots of different kinds of salts in it that give you electrolytes like sodium ions and chloride ions and potassium ions and things like that. Whereas sugar is a non-electrolyte. What that means is it doesn't break up into these positive and negative charges. The molecules stay together because they are a molecular compound. So what consequences does this have? So one of the main consequences and where these names come from is that if you dissolve an electrolyte in water, it can conduct electricity. And the reason for that is you have these positive and negative charges. They can move through the solution and conduct the charges from the electricity through the water. And so water by itself actually doesn't conduct electricity very well if you have very, very pure water. Now, it's very rare to have very pure water, and that's why we're familiar that water usually conducts electricity, but it's because of the electrolytes dissolved in it. Most water that we drink or use on a regular basis, unless it has been specifically purified and all the ions are gotten out of it, it's going to conduct electricity because of those electrolytes. A non-electrolyte solution, so if you have a solution that's strictly just water and sugar, it does not conduct electricity. So if you dissolve sugar in water and there's no other ions present, if there's not any electrolytes that are already there, it will not conduct electricity, sugar and water. Now, there is something that's in between electrolytes and non-electrolytes. And these are weak electrolytes. So I'll just mention those here before I forget to do that. A weak electrolyte is something that only partially dissolves. Or I should say only partially separates into ions. And we'll get more into this in future videos, but I just want to mention that is a possibility, and these only, as you might expect, they weakly conduct electricity. So they conduct electricity, but not very well. All right, and so that concludes this video on electrolytes and non-electrolytes and how they behave in solution.